What is up, everybody? Today we are going to take a look at some radical equations, solving some radical equations. Last time we took a look at some of the graphs of radical functions, but now we're actually going to put them equal to each other and solve them like that. So in here I am hiding a graph, and that graph is going to be the solution to this one right here. But first, we're going to actually solve some radical equations first. Rather than trying to tackle the hard, we're going to do the easy first. So the square root of 3x plus 1 total minus 5 equals 2. So if you are trying to follow on with solving the radical equations, you can just add 5 first. So 2 plus 5 is 7. And then the square root of 3x plus 1 is equal to 7. So since everything is on by square root, you do the inverse, you square both sides. 3x plus 1 equal to 49. And then x is just going to be equal to 16. Because if you subtract 1, you get 48. Divide by 3 is 16. So that's a one solution, right? X is equal to 16. Now next, what's the solution of y equals x plus 2 and y equals the square root of x plus 2? Now they're both equal to y. Since they're both equal to y, you can do x plus 2 equals square root of x plus 2 because they're both equal to y. They're both on the same graph. And x plus 2 equals square root of x plus 2. So you can subtract 2, and then x is equal to square root x. And since x is equal to square root x, you can get rid of the square root, square both sides. You have x squared equals x. And then since now we have x squared equals x, we can move them to the left side. Now we have x squared minus x equals 0. Then we go back up here. X squared minus x is just x times x minus 1. So since we factor this, we can use a zero product property. So x can equal to 0, because when you multiply, the whole thing's going to be equal to 0, or 1 when you multiply. 1 minus 1, which is 0, the whole thing's going to be equal to 0. So 0 or 1. And for this one, it's 16. Okay, so if we show the graph out right now, first get rid of the graph. There you go. See, that's x, that's square root of x plus 2, and that's x plus 2. So they meet together at this point. So that's 0, 2, and this point, 1, 3. Next, cubic and higher order level equations, whatever the heck you want to call them. Well, we're going to solve it just like we solved the square equation. So, plus 5, you get plus 5, so subtract 5 on both sides, right? So 9 minus 5 is 4. And then the cube root of 8x is equal to 4. So you can just take the cube of both sides. And then 8x is equal to 64. And then x is equal to 8. So in this equation, x equal to 8. In this equation, notice how this is put on the square root of the third root. So this is put on the power of 1/3. Now, you do not want to get tricked by this power of 1/3. It's the same thing as the third root. So we might as well just put a third root here. And then you cube both of them. You will get x squared plus 5 is equal to 3x plus 45. And if you subtract them all on the other side, you'll get x squared minus 3x minus 40, and we know how to solve a quadratic equation. We can factor or quadratic formula. In this case, there is an easy factor and pair. For this equation, it is just x minus 8 times x plus 5, and that will give you x is equal to -5 and +8. And these are the answers. Okay, next. This is called an extraneous solution. Now, an extraneous solution is a solution that appears halfway through solving the equation, but is not the solution to the full equation because of complications like quadratic formula, domain and range, imaginary numbers, and those types of stuff. So we have a A solution that appears halfway through solving an equation is not a solution to the initial equation. So let's solve this equation, right? So square that, and we can square that. So that's x squared minus 4x plus 4. Remember, it's not x minus 2. It's not x squared minus 2 squared. That is a big mistake that people make, even to this level. So equals 28 minus 2x. Now you move everything to this side, you move everything to this side, you'll get x squared minus 2x minus 24 is equal to 0. That's not a z, it's an equal. Okay, and then you can factor this to get this. And then you can get x is equal to -4 or +6. And that is your answer. However, if you put them back in, are they going to be the solution? Are they going to work as a solution of the equation? Let's check it out. Okay, -4 minus 2, is that equal to 28 minus 2 times -4? -4 minus 2 is -6. 28 times -2, -2 times -4 is +8, so square root of 36. And square root of 36 is 6. -6 is not equal to 6, so that's wrong. Now we put 6 in, 6 minus 2, is that equal to square root of 28 minus 2 times 6? Now 6 minus 2 is 4, and 28 minus 2 times 6 is 28 minus 12, so that's 16. And then 4 is definitely equal to 4, that is the correct answer. So -6 not equal to 6, but 4 is equal to 4, and 4 is the only solution. So if we check the graphs, indeed, 4 is the only solution to this equation. -6 is not equal to 6, so it's not a solution, because if it was equal to 6, we would have had this. We would have had this, which will have a solution at the 6, but there is not equal to 6. Therefore, we only have the solution at the 4. Next, I'm going to solve another equation. So solve this equation, x plus 2 plus 1 equals minus square root of 3 minus x. First of all, we'll square both sides, just like normal. Now you got the right side's easy, but you got to be really careful on the left side, because this will expand on to be a binomial. And we got to square this first, then we got to square it by FOIL. And there's a square root in there. So you don't square it like a trinomial, you square it like a binomial. And it's a little weird, because you got to square this, which is x plus 2, and then you got to square, I'll show it out like the FOIL method. So x plus 2 plus 1 times x plus 2 plus 1, square root x plus 2 plus 1. First of all, you square this, that's x plus 2, right? Then you do this, so that's 2 times plus 2 times the square root of x plus 2, and then you do this, which is plus 1. So then you actually have x plus 3 plus 2 times the square root of x plus 2. You don't have the square root, the whole square root of x plus 2. So we'll just add that in there, 2 times the square root of x plus 2 plus x plus 3, right? Actually, I already have the x plus 2 right there, so we can just do plus 1. Okay, let's erase everything. X plus 2 plus 1 is x plus 3. We can subtract x on both sides. Actually, I want to move everything to the right side, because it's no, I want to move everything to the left, to the right side, because I want to isolate the square root. I want to get rid of the square root. So we'll subtract x on this side, and then 2 plus 1 is 3, so we can just subtract 3, and then this thing will be get rid of, this thing will be rid of, this thing will be rid of. So minus x is minus 2x, right? Minus 2x is equal to 2 root x plus 2. So if we divide by 2 on both sides, we'll have root of x plus 2 is equal to just minus x. Square root both sides, you'll get x squared, because negative times negative is positive. x plus 2. Plus 2 is equal to x squared. Oh god, x plus 2 is equal to x squared. So then we'll have, subtract x squared on both sides. We'll have minus x squared plus x plus 2 is equal to 0. The x squared minus x minus 2 is equal to 0, because if you multiply by a negative, it's the exact same. And then we can do x plus 2, x minus 2, x plus 1 is equal to 0. So our two solutions should be x equals negative 1 and x equals positive 2. However, we're going to put it back in the equation. So let's see if it's true. We'll add negative 1 into the equation, right? Square root of negative 1 plus 2 plus 1 equals square root of 3 minus negative 1. So negative 1 plus 2 is 1, plus 1 is 2, 2. And then 3 minus my negative 1, that's square root 4, which is 2. So 2 is equal to 2, correct? However, if we put it down here, let's do the 2. Square root of 2 plus 2 plus 1, is that equal to square root of 3 minus 2? 2 plus 2 is 4. And then 3 minus 2 is 1. So square root of 2, 2 plus 1, is that equal to 1? No, it does not. 2 plus 1 does not equal to 1. 2 plus 1 is equal to 3. So if you see this graph right here, the two, they do intersect, but they intersect here. Because if they didn't if they were not functions, they would be like this, and they would intersect at x plus 2, which is right here. But they're not functions. They're just regular. They're not equations. They're just regular functions. Therefore, they don't intersect like that. Okay, like that. Okay. Next, solving radical inequality. Solving radical inequality. That's just simple. Square root of 3x minus 6 is bigger than 2. This is smaller than 2 this time. So we'll square both sides. You'll get 3x minus 6 is smaller than or equal to 4. We'll add 6. We'll get 3x is smaller than or equal to 10. Right? And then we'll equal to 10. And then we'll get x is smaller than or equal to 10 over 3. And that is our initial inequality. However, we've got to consider the radicand. We've got to consider the thing inside of the radical. So 3x minus 6 has to be smaller than or equal to 0. No, it has to be bigger than or equal to 0. In fact, bigger than or equal to 0. So then we'll have add 6 on both sides. 3x is bigger than or equal to 6. X is bigger than or equal to 2. So x has to be bigger than or equal to 2, but smaller than or equal to 10 over 3. So we can write the inequality as like this. 2 is smaller than or equal to x is smaller than or equal to 10 over the root of 3, and that is our answer. Now if you look at the equation, yes, that's 2, and that's 10 root of 3. And this is the equation that has to be smaller than or equal to. So this, in this domain, x is fulfills the requirements. Next, how do you see it? Use the graph to find the solution of this equation. I'm not solving this equation. This is you can solve it by yourself if you want to. But use the graph to find the solution of the equation. And I've shown you a bunch of graphs already, right? That shows you the solution of the equation. It's right there, right? And then it's right there, right? And then it's right there, these 2 points. So the solution is just them two crossing off, which is 5 over 2, 5 to the point 5 2. 55. Reasoning. Solve the equation x minus 4 equals square root of 2x, and solve the equation x minus 4 equals minus the square root of 2x. How does changing them solve the equation? So x minus 4 is equal to square root of 2x, and then you square both sides. And x squared minus 8x. X squared minus 8x plus 16 is equal to 2x. Subtract 2x on both sides. X squared minus 10x plus 16 is equal to 0. And then let me see if I can actually factor. I don't think I can actually. Oh, I know I can. I can factor this. So x minus 8 times x minus 2 is equal to 0, and then x is equal to 2 or 8. And that's our first equation. We can plug that in. 2, 4, 2. Yeah, 2 does not work because 2 minus 4 is negative 2. 2 minus 4 is negative 2. And then square root of 4 is positive 2. So 2 does not work. So it's just 8. Just going to be 8. Just going to be 8. Okay, let's solve the other equation. X minus 4 is equal to negative square root of 2x. X minus 4 equal negative square root of 2x. So now we have 4 minus x is equal to the square root of 2x. Multiply them together, you'll get 16. You'll get 16 plus x squared. So we'll do x squared, right, minus 8x, and then plus 16 because it's the exact same thing. Is equal to 2x. And then we'll subtract 2x on both sides. We'll get x squared minus 10x plus 16 is equal to 0. X minus 8, x minus 2 is equal to 0. And then x is equal to 2 or 8. If you plug them back into the equation, let's plug 2 in, right? 2 minus 4 is negative 2. The square root, that minus the square root of 4, so minus the square root of 4 is equal to minus 2. That's correct. So 2 is a correct solution. 8. If we put 8 into the equation, 8 minus 4 is 4. 2 times 8 is 8. Minus the square root of 16 is negative 4. So 8 is not a correct solution. So the solution of the first question is 2. And the solution of the first question is 8. But the solution of the second question is not 8. And I'm going to try to justify it using graphs. I'm not the most amazing grapher ever, but I'm going to try to justify it using graph right here. We'll use a graph right here. Okay, x minus 4 is probably something like this. Oh, that's a bad graph. Yeah, probably something like that. And then the square root of 2x is probably something like that. So the graph, so it intersects at 8, right? It intersects at 8. We're going to keep this x minus 4, and then we're going to do negative square root of 2x. See? Looks closer, right? Intersects at 2. It does not intersect at 8. Therefore, we have different solutions for different problems. Because if there were no extraneous solutions, they would both be the same graph. Therefore, they would both be like this. Okay, final solution. Modeling with mathematics. The length L in inches of a standard nail can be modeled by this, where D is the diameter of the nail. What's the diameter of a standard nail? That's 3 inches long. So this is just simple. We're just going to solve the equation. 3 equals 54D 3 halves. 64D to the 3 half power. So we'll divide by 54 on both sides. We'll have 1 over 18 is equal to D to the 3 halves power. And then we'll take both to the 2/3 power. Take this to the 2/3 power. We will have, I'm gonna have to do some mega factoring here and some mega so we'll have 3 to the, we'll have 1 over 18 squared, which is 1 over 324, and then we'll have to cube root that. So I'm going to have to take rather good consideration in trying to trying to get some of the trying to simplify basically. So that's equal to 3 root of 12, 3/3 root of 12 over 1. So in order to simplify that, I'm going to have to multiply to the closest. I'm gonna have to multiply to the closest. I have to multiply to 12 is 2 times 3 times 3, so I have to multiply by 18. So I'll multiply this top by the cube root of 18 as well. We'll get cube root of 18 over 3 times 6, 18, and then that's our correct answer, which is roughly equal to roughly equal to, I'd say, 8, 18, 32, 27, roughly equal 1.5, 2.5. So it's roughly equal to about 0.15 diameter in inches. So that's gonna be it for today's episode. If you want more course videos, as I said, I was gonna be trying to upload a new course today. Um, just out of my own interest, because obviously none of you are trying to comment in the comments. If you want new course suggestions, comment in the comments, because I'm uh, I'm going to continue these. But if you want more course suggestions, I might start making more videos, because there's more pressure on me to make videos if there's more course suggestions. So if you want more course suggestions, just tell me, okay? And then see you next time for the integrated 4.5, which I think is solving more equations.